Hello students, today we will explain a pattern of sums that is both used for class 9 and 10. That is how to prove a number is irrational. As we know, irrational number means the number that are not rational, and the examples are say root 2, root 3, root 5, as well as I have also already in my previous class explained pi is also an irrational number. Now, how to prove those numbers within the square root that are irrational? So here there are three types of sums. So three patterns are there. One by one we will discuss. Now the first pattern, how to prove a number when it is given single irrational number. That means only irrational is given. Then how to prove this type of numbers as irrational. So what we do when to prove a number is irrational, the method that we apply, that is simply we call a contradiction method. Why contradiction? To prove irrational, we will consider the number as rational. And when on doing the sums, when we will see that what we have assumed earlier that is wrong, that is against our assumption, then we can say that it is not whatever we thought or we have assumed. That is called contradiction method. That means it contradicts our assumption. So same way we will do. So here is the first type when the number is given alone, single number. Root 2, root 3, root 5, root 7, whatever it is given, how to prove this type of sums. So, if possible, let us assume that it is a rational number. That means we will consider it as rational. So, rational number definition we know, a number of the form p by q. So, we are adding, since it is rational, we are considering, so root 3 equal to p by q, where p and q are co-prime integers. Don't forget to write co-prime, because co-prime means they are prime to each other. Co-prime integers and q not equal to 0. This is our first part. Whatever the number it is, root 2, root 3, root 5. Then here in this type what we will do, we will square both the sides. So squaring both the sides, root 3 square is equal to p by q whole square. So root 3 square will become 3, because root 3 into root 3, it will become 3, and p by q whole square will become p square by q square. Now on cross multiplying, what we will get? P square equal to 3q square. Correct? Okay. Now what does it mean? So after that, what you do? You will recall a theorem. What is the theorem? If p is a prime number and p divides a square, any prime number, p is a prime number, and if p divides a square, that means square of a number, then p divides a also, that means p divides its square root. Suppose one example I have written, if 7, a prime number, if 7 divides 14 square, that means 196, then 7 will divide 14 also, that means 14 also is divisible by 7. In the other way, you can say this. So that is the theorem. Now based on this theorem, now what can we write? You see, 3 divides p square. That means p square is divisible by 3. You can write according to your own language. So if 3 divides p square, then by the theorem, what can you say? 3 divides p also. That means p is divisible by 3 also. So if p is divisible by 3, so we can assume p equal to suppose 3k. You can take some other constants also, 3m also you can take, that depends on you. Now if I take p equal to 3k, again squaring both sides, p square equal to 3k whole square. So it will become 9k square. Now putting the value of p square as we got earlier, 3q square, what we will see? Q square is equal to 3k square. What does it mean? That 3 divides q square, or q square is divisible by 3. So if 3 divides q square, So by our theorem, what can you say? 3 divides q also. Now you see one thing. Earlier what we got? 3 divides p. And now what we got? 3 divides q. What does it mean? It means 3 divides both p and q. What does it mean? Therefore, 3 divides both p and q. That is, what does it mean? If 3 divides both p and q, what does it mean? It means they have, that is, p and q have a common factor 3. Yes, because 3 divides both p and q, that means they have a common factor. But you see, when we have assumed, what we have assumed? P and q are co-prime, that means they don't have any common factor between them. But what we are getting now, they have a common factor. Means what? What we have assumed, that is wrong. Which contradicts our assumption. What we have assumed? We have assumed that root 3 is a rational number. Contradicts our assumption means what we have assumed, that is wrong, against the assumption. So if root 3 is a rational number that we have assumed, that is wrong, that means it is not rational. So when not rational, then it is an irrational number. So therefore, root 3 is an irrational number. In this way, we can prove this type of sums. Now, the type 2. What is the type? Here you will get a combination of rational and irrational number. 5 minus root 2, suppose we are taking an example. It can be plus also, 3 plus root 3, whatever the number is. But in this pattern, you will get a combination of rational and irrational numbers. So in those cases, what we will do? Same process, we will consider the number as a rational number and we will prove it by contradiction method. So when we will assume it is a rational number, see here we are writing, if possible, let us assume that it is a rational number. If it is a rational number, we can express it in the form p by q, where p and q are co-prime integers and q not equal to 0. So in these cases, we will not square it again. It will become very easy. What we will do? Our aim will be keep the irrational number separate and all the other terms together. That depends on you, how you do. So here you see, we are bringing p by q, transposing in the other side and taking root minus root 2 to the other side. And then we are getting, by taking LCM, 5q minus p by q is equal to root 2. That is, our aim will be keep the irrational number separate and others all separate on the either side of the equal sign. This is the first job. And then you see, we have taken p and q are integers. So if p and q are integers, so an integer by integer will become what? A rational number. That you have to write clearly. Since p and q are integers, therefore it will become a rational number. So if it is rational, if 5q minus p by q is rational and equal to root 2, what does it mean? It means root 2 is also rational. So therefore root 2 is also rational. But is it root 2 is rational? No. Because root 2 is an irrational number. So here what we will do, the statement you will see what we are writing, which contradicts the fact that, because we have not assumed root 2 as rational. So that's why you will not write that which contradicts our assumption, because we have not assumed root 2. We have assumed the whole 5 minus root 2. So that's why what we are writing, which contradicts the fact that root 2 is irrational, because originally root 2 is irrational and here we are getting rational. So that is contradicts our assumption. That means what we have assumed, that is wrong. So if we have assumed it is rational and it is wrong, so what type of number it is? It is an irrational number. Okay, this is the second pattern. Now the third pattern. What is the pattern? In the first pattern, what we got? A single digit irrational number, single irrational number, root 2, root 3, 1 by root 2, 1 by root 3, root 5, root 7, like this way. In the second pattern, what we got? The combination of rational and irrational number, 5 plus root 2, 5 minus root 3, in this way. And the third pattern is both the numbers are irrational. Say here one example we have taken, root 5 plus root 3. It may be plus or minus, any number. That means a combination of two irrational numbers, separating them by plus or negative sign. So here what we will do, process is same, a little bit steps will increase. See, first of all, the first part is same. If possible, let us assume that it is a rational number. That means we will do by contradiction method. So if they are rational, root 5 plus root 3 is rational, so it can be expressed as P by Q form. So writing, therefore root 5 plus root 3 equal to P by Q, where P and Q are co-prime integers and Q not equal to 0. Then what we will do, we will squaring both the sides. On squaring both the side, it will become root 5 plus root 3 whole square is equal to P by Q whole square. Now it is in the form a plus b whole square. So a plus b whole square formula we know, a square plus b square plus 2 into a into b. So expressing in the form, what we are getting, root 5 whole square means 5, root 3 square means 3, root 5 into root 3 is root 15. So it will become 2 root 15 is equal to p square by q square. This 5 plus 3, 8 will go transpose to the other side and it will become minus. And then keeping, here also same technique, keeping the irrational part separate and everything on the other side of the equation. So keeping root 15 on one side and everything on the other side, that is our aim. Now P and Q we have assumed as they are integers, so integer by integer it will become a rational number. Okay, so what does it mean? We are getting that p square minus 8q square by q square, it is a rational number. So if it is a rational number and it is equal to root 15, means what? Root 15 also rational. But is it true? No. So that's why written, which contradicts the fact that. Why writing the fact? Because we are not taking here that root 15 is a rational number. We are taking the whole root 5 plus root 3. That's why writing, which contradicts the fact that root 15 is an irrational number. If root 15 is irrational and we are getting root 15 is rational, that means what we have assumed, that is completely wrong or against. That's why writing, therefore our assumption is wrong. So our assumption means what we have assumed, it is rational. If it is wrong, that means it is an irrational number. Understood? So these are the three different type of sums. Okay, is it clear?